Hello everyone. I was going to take the time to walk you through an app that I've came across called Autodesk Force Effect. Now if you're familiar with Autodesk, you know that they're real famous for AutoCAD and Inventor softwares. Inventor being like a 3D software, and then AutoCAD pretty much being the staple on 2D drawings and 2D design software. What this software does, the Force Effect, is it allows you to do a structural analysis of a particular part or product or element that you may have. So I was going to take the time and walk you through just a short example on how this system works and how I feel it's beneficial to the engineer. So I'm going to start by removing the last little thing I did there, and you can see I can resize the drawing here, and I kind of got it set up on a standard engineering paper right now. Anyway, so what I'm going to do is I've got this little over here in this corner, I've got this little toolbar that allows me to put things in. Like I've got a select icon and I've got a line icon. So like this right here is going to allow me to put an element into my drawing. So let's say I'm just going to do a simply supported beam. So see, I can just take and draw essentially what is a beam straight in there, and you see it automatically pops me up a dimension. If I need to change that, like I'm dealing with 0.45 meters right now, or 450 centimeters. Let's say I wanted that to be 650. I would just enter in that number. Of course, I need to make sure I got my decimal place, or else it'll make it huge, right? 0.65. I'm going to hit done, and it automatically will resize that for me. Now, if I go back and hit select, if I select this guy, see, it'll pop up my dimension on it, and it also will highlight it in green. Now, the next thing that you'll notice is up here in the upper right, this little triangle fulcrum level point like that, and pretty much what that's telling you is how defined your system is. So like right now I'm dealing with an underdefined system, and the software can't really solve any equations for equilibrium. So I need to tell it a little bit more information so that it can solve the particular problem that I'm going to have. So now if I come back over here and select the little triangle, this is going to be like my supports. So see, I can do a roller, I can do a pin joint, I can do a fixed joint, and I think what I'm going to do on this one is two fixed points. So like maybe this is like a shaft that supports bearings or something of that nature. So I've got it highlighted in orange, and I'm just going to pick a spot, and I'm going to pick another spot. So I put those two in, and now if you look at that, now I'm dealing with a fully defined system, and I can, it's solvable. Now it knows exactly what's going into it and what it needs to solve. But now what it doesn't have is the loading, so I'm still not going to get any information, right? So I'm going to tell it a little bit more. And see, I can set the links from the end. I think I'll do that. So let's say they're 0.15 from each end. So we hit done. Come back and select this guy. Select this one. Tell it that it's. Oh, thought I'd show you that too. You can also see that I can click it and drag it, and that'll change the numbering for me. So sometimes you can't hit exactly what you want, but you can get it close, and then just tap on it, right, and then just manually input it. Alright, so now we're set up, right? So now I need to tell it a little information about loading, right? So let's say we've got these two supports, right? Maybe we're doing like a basic fatigue test or something like that. So this guy's going to be loaded dead in the middle. So I'm just going to pop that little guy up there, and it's going to ask me for some information like how's it loaded. Well, so how is it loaded? Let's say, and it works in kilonewtons. So let's say I'm putting what's reasonable here. We'll do something simple. We'll say we're putting 50 kilonewtons on it. So maybe a heavy piece of industrial equipment or something like that. And you can see as soon as I tell it a loading, it automatically pops up my reaction forces. So how cool is that? So I already know what my reactions, if I wanted to design those, I already know how much load that they're going to have to support. So I kind of already got a basic idea where to go for material selection and things of that sort. Of course, very basic. When you get into that kind of stuff, fatigue loading, that kind of thing, it's there's a lot more variables than just the actual force being applied. Anyways, let's see. Let's get this guy in a different location. So let's say, so I got 0.65 on it. Let's say I wanted that to be dead in the middle. So I would just pick that one. And then I would tell it, see what we're going to do it with. We're going to do it with 0.325. So now we're set dead in the middle of the beam. And that's it. Now I got my reaction loading and all that. So that's basically a solved beam there. But now if I come up here and if I pick this little guy right here that's got the sum symbol on it and it looks like it's written on a piece of paper like sum equals, I'll pick that and you'll notice the the app will open up and it'll give me a basic sketch of what I've drawn with my reactions included, solved on that. It'll tell me elements that I've got involved with it, and of course it's from A to B. Makes perfect sense, right? The forces that are on it, what their angle is with respect to the beam, and then it'll give me. This is probably the most coolest part. It'll give me the results from solving it. So now I have an actual value and direction and angle from where it's performed the basic equations. So this is a good check. Like if you're a student, you could download this app. Maybe you're going through a statics course, or sometimes even dynamics course would involve a basic statics summation or solving reactions, that kind of thing. So see, now you've got a means to check your own answers as you're going through your work to help you prepare for tests and homework. So now getting into some more things. Of course, being in the industry, this is just really saving time, because now you're not having to sketch out everything and do it all by hand. Now you got a means you can just draw it in, tell it what its loadings are, and it'll automatically compute the data for you. So obviously saving time from an industry perspective. So now getting into some more things, it's going to draw you another sketch out, and this is kind of getting into the shear and moment side of things. It'll draw you these shear and moment diagrams for that beam. So now it's real easy for me to tell that my maximum shear occurs right here at the 50 Newton load, right? That's where my greatest difference is between those two. I go from 25 to negative 25, so that being 50. So the greatest shear point on the beam will be located here. Also, that will also be the location of my greatest moment, which comes from this point right here, right where it crosses I guess this would be the x-axis again. that point right there where the shear is 0 is where the maximum moment occurs. So I also have information about that. So why is this important? Well, this is important because it'll cut down time and for you actually doing this, solving out the paperwork and or solving out the equations yourself by hand, and we'll go ahead and throw you right into your shear and moment diagrams. So now if you're wanting to actually do a fatigue analysis, you've got the information for that. And of course you know your loading, like maybe you're dealing with 0 to max loading or something of that sort. You can just jump right into finding your other information that you're going to need to determine a factor of safety or a endurance limit, things of that sort, material selection. So very helpful in that regards. And you can, depending on, I guess, your software, see I've got a share icon up here. I can just click it and it'll let me email that out to whoever I would need to email it to, and you can download the report and actually print it out. So you've got a hard copy too if you need it. So it's very functional from a standpoint of being speedy and effective. So we'll go back now, and that will be pretty much the end of that little demonstration there. Thanks for watching.